In this lecture we are going to discuss about the detection methods for the double sideband in full carrier. We know that there are four different methods of detection that we can use in order to detect the modulating signal from the modulated waveform. The first one is the square law detector. As the name square law detector, so it means that we will use non-linear device in order to detect the signal. The first one is the waveform. If we draw the waveform, so we know that the waveform is something like this. If this waveform is inserted in the square law detector with DC blocker, then we will end up with the output. So that one is the empty. This signal is basically AM, amplitude modulated signal, which contains carrier and the empty. So this is empty and this one is CT. And if we use square law detector, we can get the message signal back that we have transmitted from the transmitter. So we can write a block diagram. Block diagram of the square law detector is AM modulated signal, you can say phi of AMT, which is going to input into the square law device. And then after that we will get one output, so that is V1T, and then pass that output through the low pass filter, and then you can use DC blocker, and then you will end up with M of T signal. So we know that our amplitude modulated signal is equals to AC 1 plus modulation index MT with the cos omega CT. So that is the signal, and we know the relationship of the square law device like V1T. So this is the output VOT, and then you can say YT. So we know V1T is equals to A1 if this one is XT. So A1 of, so if we said this is XT plus A2 XT square, and we know so that this one is equals to so XT. So we can insert the value of XT in this equations. So use XT, and then we can say okay, V1 of T is equals to A1 AC 1 plus mu MT, and then cos omega CT plus A2T AC MT cos omega ct whole square. So that we can use, and then after that we can open the square, and then the result is, so this is a1 ac. So if we multiply the signal here, a1 ac, and then cos omega ct plus a1 ac mu mt cos omega ct plus a2, and then we can open this square, so ac square, and then 1, so this one plus mu square m square t plus 2 mu mt, and then you can multiply it by cos square omega ct. So you can rewrite this equation again. So you said it is a1 ac cos omega ct plus a1 ac mu mt cos omega ct plus a2 ac square. So you are keep multiplying ac square cos square omega ct, and then plus a2 ac square mu square m square t, and then cos square omega ct, and then plus a2 ac mu mt and 2 cos square omega ct. We know that cos square omega ct is equals to 1 plus cos 2 omega ct, and then divided by 2. So so that is the basically output of a square law device. So we know that the frequency of this signal is fc, and the frequency of that signal is again fc. The frequency of this signal is again, so you see it's cos square, so it means that 2 fc, and the frequency of this signal is fc, 2fc plus minus fn, and then here so you see this one is again, so if you write that as compared to this one, so you can say okay, so this one basically y1 t, and then so you see if you pass that signal through the low pass filter, so this will be cancelled. It will not allow to pass this one, it will not allow to pass this one, it will not allow to pass this one. So which signal only the signal that it will allow to pass is BAC square. So it will be BAC square. So it is AC square divided by 2, and then so the remaining one is 1 plus mu square m square t, then plus so 2 mu of mt plus a2 AC square divided by 2, and then plus a2 AC square divided by 2 mu square m square of t. So that is the output of the VOT after passing through low pass filter, because this is the frequency of this signal is FM. So this is the frequency of signal is 0, the frequency of this signal is again FM. So if you pass that signal through the DC blocker, so after DC blocker, it will block the DC term, and the remaining is that y of t is equals to AC square divided by 2, and then 2 mu of mt, this will be cancelled out, and then plus A2 and AC square divided by 2 mu square m square d. So you see, this one is AC square mu of mt plus A2 AC square divided by 2, and then this one is mu square m square t. So we have two signals at the output. The first one is the desired signal, and second one is noise. So that is the distortion. So usually there is a noise always, and then you can minimize the noise using the signal to noise ratio. Signal to noise ratio, you can say power of signal divided by noise power. So like you can minimize the signal to noise ratio using that term. So it means that if you said that is your signal, so signal is A1 AC square mu mt and divided by A2 AC square by 2 mu square m square and t. So square will be cancelled with that, so square will be cancelled with that one, and then again you have that should be much bigger than 2, so that 2 can be on the other side. So you can say okay, so the remaining signal you have A1 or mu A2 mu of mt equal to 2. So it means that you can say that the mu should be much less than 2. So by varying this criteria, you can minimize the noise, and then you will end up with the desired signals, that is A1 AC square mu of mt. So like if you maximize the power, so it means that you are minimizing the noise. So that is the detection if you use a square law devices. So you can use a circuit diagram if you like. Circuit diagram of the square law devices is non-linear device. So you are giving signal to the non-linear device, and then you are using low pass filter, and then you are using DC blocker, and then so this is your MT, RL, CB, and then this is C, this is R, and then this is the modulated signal. So that is VIT, and this is V1 of T, and then this is maybe 2T, and then here we have YT. So that is the circuit diagram of this. So that's all for the square law detector. I hope you understand this device very well, but if you still have any question, you are most welcome. You can write your question in the comment box. Thanks for watching the video.